So now let's talk about the ellipse. So the ellipse, we have to get this idea of this diagram down kind of in our memories fairly solid. So let's see if I can draw a reasonable looking ellipse. It's a little bit more rounded on the ends, but not so football-like, but that's close enough, I think. So we have this thing that is our major axis, and it has two endpoints. Major axis is in orange, and it has a length of 2a. So that means that this distance is a, and the other a is over here. Okay? We're not going to want that one on there. It's going to get too cluttered if I leave it on there. And then I have this vertical axis, and since it's shorter, this one is referred to as the minor axis. And the minor axis has a length of 2b. And so that means that this distance is b, as well as this distance. And then this point in the middle is called the center point, okay, or the center. Probably get rid of that stupid p. The center, and it has coordinates h comma k. H comma k, what? Well, we're going to have to write down the standard form for an ellipse here shortly, but we're going to get the diagram so we can point to some of those values. Then I have these two blue points over here, and they're each a focus point, so they're called foci, the plural. It's also acceptable to say foci. If you're in America, some European countries pronounce it foci and foci, but that just sounds like some kind of Viking lord or something to me. So this is the diagram we're going to reference with regard to the ellipse, and the equation looks like this. This is also length c. So the equation looks like this. Well, x minus h squared, it could write it the other way, it doesn't matter because it's addition, but we're just in the habit of writing it in this direction. A squared over b squared, and all of that's equal to 1. And that is your ellipse. Now, there are one way to look at it is there are, quote, two versions of it. And the difference between the two versions, if I swap a and b. And so if a is always the major axis, if a is always the major axis and b is always half the distance of the minor axis, if I switch this a and b, meaning my formula now looks like this: x minus h, the quantity squared, plus y minus k, the quantity squared, over a squared. Notice how the a is under the y squared term. B squared's over there. Whichever term has the greatest value, which in this paradigm it's always the a is longer, is greater than b. So then this one becomes our vertical because my greater value is underneath the y. Or if a is under y, and horizontal if a is under x. So that's that guy, that's that guy. I don't much think of it that way because when you're presented with stuff, you're not really given the a and b so much. It relates to this diagram, but you're really not given an a and a b. You're often given this information. So let's go right into an example. And so we have, let's go, x plus 3 squared plus y minus 5 squared over, 49, and let's make this 64. That's going to be equal to 1. So that, hopefully you go, wait, is this an ellipse? And yes, this is the standard form for the equation of an ellipse. And again, the first question, whether you're talking about the ellipse, the parabola, or the hyperbola, the first question should always be, is this horizontal or vertical? And so if I ask that question, for the ellipse, I look to see which of these two values is greater. And so this one's greater, so I can think about this as being x plus 3, the quantity squared, plus y minus 5, the quantity squared, over 7 squared, 8 squared equals 1. This is the larger of my two denominators, and therefore, and it's underneath my x squared term, so that means my ellipse is horizontal. Because my longer side is on the horizontal, the x-axis. Second thing you want to do is draw. So now that I know that it's horizontal, I want to do this. And it's a poor sketch, but it's good enough. So I'm going to make this guy orange just so we can see what's going on here. And I know that my major axis is 16 units long, which means that this part, which is my A part, has a length of 8. My B part, I guess I should have done a different color. Let's fix that. Is B, and that's equal to 7. So the thing's almost round. It's almost circular, I should say. So now that we have those things down, the third thing I want to do is find my center point. And my center point has the coordinates HK. And so in this case, my H is -3 and my K is 5. So my center point is -3, 5. And so now, at this point in time, it depends on the question that's being asked. But what I'm going to do is I'm going to show you how to find all 4 endpoints, and then we have to do a different problem. Okay, so let's find determine endpoints. It's not always what's going to be asked of you, but it would be a somewhat common thing to ask. So I have 4 endpoints. I have these 2 endpoints of the minor axis, and I have 2 endpoints of the major axis. So first of all, I'm going to write down the center point as, I'll write it in blue, as -3, 5. So -3, 5. And so my upper minor endpoint is going to be 7 units, B units, 7 units directly above that center point. So I'm going to take my y value, 5, and add 7 to it. So my first one looks to be -3, not my first, one of my endpoints is going to be 7 and 5 is 12. And the other one is going to be 7 units below this 5, and so that's going to be -3, -2. And so hopefully you see what's going on here. For these 2 endpoints, I'm just going to be adjusting the x value with the factor of 8, or by a distance of 8. And so for the left endpoint, I'm going to have -3 -8 because I'm going in the negative direction 8 units. So -3 -8 is going to be -11. My y value didn't change because they're on the same horizontal line. I should say and. Oh, poop. Okay. And the other one is I'm going to add 8 to 5 to go in that direction. Excuse me, add 8 to -3 because I'm going into the positive x direction. So -3 plus 8 is going to be 5. The y value didn't change, so 5, 5. So another example problem is an orbit problem. And here's the problem I'm trying to get to. Okay? And I'm not sure if this is the most direct or simple or efficient way to do this problem, but this is how I see it. So what it basically asks you is, or tells you first and then asks you, it tells you that the distance of the Earth, or some other planet like Neptune, is some distance, and let's say it's the Earth one, 147.09 million kilometers from the Sun at its closest approach to the Sun. So the closest it ever gets to the Sun is 147.09 million kilometers. Now, that distance is equivalent to the distance from the focus point here. Let's do it in blue. I did it in yellow because I was making it the Sun. But it's a focus point to the end point of the major axis. So I'm going to draw an axis in here. I'm going to do it in purple. Okay, that's your major axis. Your minor axis I'll do in red. That would be something like that. And so this distance on the major axis, of course, is A. And the other focus would be something like this. And in one of the classes, we got hung up on, because I drew the other focus there, and we got hung up on the idea of like, what the heck is over there? I think somebody might even thought that that was the Earth. The Earth is this guy right here, this blue dot right here, because it's traveling along its orbit. This is just another focus point. So in space, there more than likely is nothing there. It'd be strangely coincidental if one of the other inner planets actually happened to pass through the focus point of the Earth. That would be really weird. But in any case, it could happen. I have no idea the details of the planetary motion. And then we have this center point. Okay? So the question gives you this information, and that's all they give you. Oh, I'm sorry. They give you another value called the eccentricity. Eccentricity, which is a measure of how not circular an eclipse is. Which means if the eccentricity is 0, we have a circle. And that's what helps me remember what eccentricity is equal to. It's equal to C over A. And why does that help me to remember it? If C, the distance from the center point to the focus, is equal to 0, I no longer have an ellipse. I actually have a circle. So again, E, eccentricity, if it's equal to 0, I have a circle. So if C is equal to 0, 0 over A is 0, I get 0. If I somehow accidentally flip the relationship and said E is equal to A over C, that can't work, because if C is 0, I'm going to get something over 0, which is undefined. It doesn't make any sense with regard to it being a circle. So in this case, they also gave us that E was equal to 0.017, and it's just a number because it's a distance divided by a distance. So they've given us these two pieces of information, and they asked the following question. What is the distance from the Earth to the Sun at its farthest? So as far as the Earth can be from the Sun, what is that distance? Okay? So to calculate that distance, so to get that distance, we're going to do some calculations. First, we have to figure this out. What is the relationship to this number, this 147? Oops. What relationship does this number, 147.9, have to A and C? So let's look at this. This 147.9, I'll highlight it in yellow again, is that distance. Let's say the blue value is C. That's this distance, C. Let's get rid of this. And then A, we're using purple in this problem, so A is this. So doesn't it look like if I take 147 and change and add it to C, that's going to be equal to A. 147 plus C is equal to all of A. Okay, so hopefully that makes sense. So I'm going to transcribe that relationship down here. 147.09 plus C is equal to A. I'm going to solve for C. Why am I going to solve for C? Because I have this other relationship, this eccentricity, E equals C over A, where E is 0.017 is equal to C over A. You could solve for A and then substitute it in here. I don't think that that's typically what you would prefer, because it's going to have a fraction with two terms. I think you're going to want to take, and I want a better color here, you're going to want to take this, solve it for C, and then substitute into that C. Okay? So C is going to be equal to A minus 147.09. And so now I can take this and substitute it in for the value for C, and so I get this. 0.017 is equal to 147.09. Oh, A minus, sorry. A minus over A. And I do need this. Not like that. And I do need, I do need this. Okay, so now I have this going on. All right, so we're going to do a little algebra here. So I'm going to multiply both sides by a, and so I'm going to get 0.017a is equal to a minus 147. Then I'm going to subtract a from both sides and get the following. 0.017a minus a is equal to negative 147.09. Then I'm going to factor a from both sides, from both of these terms, excuse me. A is equal to 0.017 minus 1. And so I get the following. A 0.017 minus 1 equals, I'm just copying it down because I shifted because I'm tight in this little space here. So I'm going to do that subtraction. And I'm going to take this and go, what, 0.017 minus 1. And I get negative 0.983. A equals negative 147.09. Now I'm going to divide both sides by negative 0.983. Negative 0.983. And so I get A is equal to these two numbers divided. So that's 147, 147.09 divided by 0.983. If you're wondering why I didn't put the negatives in, because negative divided by negative is positive, so I don't really have to worry about it. And so I figure out that A is 149.633774161, right? But if we go back and look at the diagram, this is my focus, this is my endpoint, this was 147.09. I figured out my A value was 149.634. But what I remember, what I wanted to find out, what I wanted to calculate was this distance. Here's the sun. I want to know the distance that the Earth is from the sun when it's its farthest point away. So I actually need the orange segment. So I have this guy, but I don't have this part. I could go back and calculate the C value, but couldn't I also do the following? This is A. This is A. Couldn't I take the following, 149.634, multiply it times 2, and then subtract that part, and I would have the orange, which is what was left. So if I take 2 times A, 149.634, and subtract 147.09, I'm going to get what? So that's this 149. I'm going to multiply it times 2. That's this part. And then I'm going to subtract. Oops, what happened there? I didn't have to hit the equal sign. And then I'm going to subtract 147.09. And I get 152.18. And that is the answer that we're going to type in. 100th is 152.18. So let's type that guy in. 152.18 million kilometers. And we're going to submit the answer. So think about that. It's 152.18 million kilometers. Okay? So I think that's, we worked with this one problem with the ellipse. We determined the endpoints of the ellipse. And so I'm going to give you the summary slide for the ellipse, which is actually this this yellow and red stuff. It's that stuff right there. So I want to erase this. Sorry. So here's your summary slide for the ellipse. Okay? So if it's a vertical ellipse, all of these calculations are true. if it's vertical, and if it's horizontal, all these calculations are true. And those were correct on the board. I do not... oh, I forgot to give you that calculation. Oh, poop. Yeah, so I'll just tack this on the end. We're going to do another problem, just so I can work this other situation in. So we calculated the endpoints over here, but we didn't calculate the focus points, or the coordinates for the foci. So I'm going to give you another example problem. Let's see. Let's go x minus x minus, I don't know, 3 squared plus y plus 7 squared. Let's go 9 and I don't know, 16 equals 1. Okay? So the first question is this horizontal or is this vertical? The larger value is underneath my y, so that means I have a vertical parabola, or a vertical ellipse. So my ellipse looks something like that. Hopefully much better drawn than that, but it's not critical. And I don't think I need the calculator anymore. No, so we can get rid of that. Okay? And so I have a major axis. This can be viewed as 4 squared. This can be viewed or thought of as 3 squared. So I have a major axis that has length 4 here and length 4 here from the center point. And I have a minor axis that has a length 3 here and a length 3 here. And I have a center point that, and I'm drawing my picture, so that was step 2. Step 3 was find my center point, and my center point has coordinates 3, comma, negative 7. So this has 3, comma, negative 7. Okay? I'm not actually going to find the endpoints because we did that above, but we're going to find the coordinates of the focus point, or the foci, or each focus point. So how do I do that? First of all, I need to know this distance c, which I currently do not have. I do not have c value. So when I talk to you about these values being a and b, or b and a, depending on which one's longer, etc., I just simply do not think of it that way. I think of one is some number squared, the other is some number squared. Whichever the number is larger, that tells me whether it's vertical, if it's under the y squared term, or if it's horizontal, if it's under the x squared term. The focus points are always on the major axis. Think about it, I have to stretch it out to make room for the focus points. That's just a weird way to think about it. So in this case, since our ellipse is vertical, my focus points are vertically aligned on the major axis. They're always on the major axis. So I don't know this distance, so I cannot get these coordinates for these two focus points. So I need this value for c. Now, there's a relationship that exists that I did not draw or go over. It has to do with these two values, this d1 and this d2. And it turns out that d1 plus d2 is going to equal 2 times half the length of the major axis, or said in a cleaner way, d1 plus d2 is equal to the length of the major axis. Do some algebra and some substitution and such, and we can get this relationship. And so typically we're finding the c squared, or the c value, and so I think of it like this more often. And that's the arithmetic you're going to do. But if you do it like I do, where a and b don't matter, no location doesn't matter, you can end up getting a negative value here and end up taking the square root of both sides and the square root of a negative number. And that might confuse the bejesus out of you regarding I'm taking the square root, I have an I value. No. These are all distances. And so what we end up having to do is this is always going to be the larger value. That's always going to be the lesser value. That's why they switch the a's and b's around, so they can just tell you this. And I would say just write it this way, and you'll never have an issue. Who cares which one's A, which one's B? Square them both, take the difference. If it's negative, wipe it out with an absolute value, and then so you take the square root. So specifically with this problem, I have 9 squared. I'm sorry, not 9 squared. I have 9 minus 16. absolute value equals c squared. Or if you prefer, 16 minus 9 equals c squared. It doesn't matter. We get the same thing, right? So 16 minus 9 is 7. So I get 7 equals c squared. Take the square root of both sides, and I get c equals the square root of 7. Plus or minus the square root of 7, but we disregard the negative because it is a distance. So I get c is equal to square root of 7. So that means this distance, this blue distance, is the poopy face. This distance is the square root of 7. So that means from the center point, which is right here, I have to go up the square root of 7 from negative 7 and down the square root of 7 from negative 7. And in fact, I still needed the calculator. And so let's calculate what the square root of 7 is. Square root 7, that's 2.64. And Hawks doesn't care if you're using the decimal here. And I believe the problem always defaults to 2 decimal places for this particular problem. So I have 2.65. So what's happening is I'm going up 2.65 from negative 7. So this is going to be, this focus point is going to be at 3, comma, negative 7 plus 2.65 is negative 5, negative 4.35. And then this one's going to be 3, and then negative 7 minus 2.65 is going to be negative 9.65. And so those are the coordinates of my focus points, or foci. And that's something that you're going to be asked to do. All right? I guess Miss Edge doesn't like to speak. So hers is not as accurate as some of these people that are using compasses, but I just want you to see this part, really. If you just keep that taut, keep the string taut, you can draw a compass. Or excuse me, you can draw an ellipse. So we were looking at this, I jumped off and we looked at this sort of compass or whatnot. So what I want to do is, so this, you can see that this could go all the way around if we made the slider big enough and would just loop, 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 loop. This K value is your vertical shift, so it's no surprise that when I change the K value, the ellipse slides up and down. And there's no surprise if I adjust this H value, that's a horizontal shift, so it's going to slide left to right. So that should be a relatively comfortable idea for you at this point, irrespective of what how you were taught this information in high school. Sorry about that. Now A, remember A is half the length of our major axis, so it's the distance from the center to here in this particular case. But if I make A less than B, it will become the minor axis. So watch this: when A gets closer to the value of B, these slide in. And what happens when A is exactly equal to the value of B? we end up having a circle when they're exactly the same. So watch when I slide U now. It's acting just like the radius of a circle. Okay? So that's why I called that other thing an elliptical compass, the string thing that Mrs. Edge did. So now when A becomes less than B, I shift to a vertical ellipse. My K is still a vertical shift. My H is still a vertical shift because remember, H is being applied to X before we do anything else. K is being applied to K is being applied to Y before we do anything else. And then this, again, A value when it's less than B. If you're going to keep track of your A's and B's and swap them, unlike what I suggested in class, then this now just became B because it's my horizontal value and it's less than my B value up here. So this becomes your B and this value becomes your A. So the distance from here to here, okay? But I'm suggesting who cares? It doesn't matter which one has what letter. Q, Z, A, B, R, doesn't matter. The eccentricity, 0.83. Remember when I said when these were equal, when we were doing the orbit problem? When these are equal, my eccentricity goes to 0. So as I get the 2.5 pow, eccentricity is 0. Why? Because the value for C, not this one, the value for C, the distance between the center and the focus and a single focus is 0. And so I get 0 divided by A, which is, of course, is 0. Okay? So that's pretty much the ellipse. Hopefully that helps.